Hello and welcome to Crazy Math Productions. Today we're continuing our unit on exponential functions, exponential expressions. Today we're going to be actually graphing these exponential functions, and we're just going to be looking first at a table of values, then we're going to be looking at this family of functions in general and how we can predict how exactly it's going to be lying on the graph. Okay, so first of all, table of values, if you remember, very powerful. There's some different methods for linear functions that we can use for graphing that may go a little quicker, but again, for many different families of functions, we can use the table of values, and it's very, very effective. So we're just going to start off, put a little t-chart here. Now, you can use a variety of different things for your x values. We're usually starting off with 0, -1, and 1. It's a very basic set, but we're also going to add -2 and 2 for this, just so that we can get a little better idea of what exactly is happening with this function. So we're going to plug in y equals 2 to the -2nd. Well, remember we had talked in an earlier section about the Chuck Norris scaffolding, so we're going to put this divided by 1, and to the -2, Chuck Norris's girl is going to beat him down. So we have 1 over 2 squared, that is 1/4. Okay, and again to the -1, 2 to the -1st, two-story house, Chuck Norris beats him down, and 1/2. 0 power. 2 to the 0 power, anything to the 0 power besides this situation is going to be a positive 1. This is actually saying that there's the same number of bases on the top of a fraction as there are on the bottom. So they're going to naturally divide to the number 1. And now we have 2 to the 1st power. 2 to the 1st power is just 2. 2 to the 2nd power. Again, I'm plugging in these x values here in the x. So 2 to the 2nd power, that's 2 squared, which is 4. And now we want to graph these on the coordinate plane, the Cartesian plane, if you will. -2, 1/4. -1, 1/2. 0, 1. 1, 2. 2, 4. And we're going to get as close as we can. Now, you can pretty much predict here. We've got 1/2, 1/4, 1/8, 1/16. It's going to get infinitesimally close, but it never goes below 0. In fact, it never actually touches 0. It's very, very close. Now, I'm just doing this by hand, so bear with me. Now, that's not that great. It should be a lot smoother. And there we go, the best I can do. It's going to get closer and closer and closer to this y equals 0, this horizontal asymptote. The domain of the range, well, that's actually going to have something to do with this. You notice that this is going to get very, very close, but not quite, to this horizontal asymptote here. That is the line y equals 0. And again, I call that an asymptote. Basically what that means is that the function itself is going to get closer and closer and closer to this horizontal asymptote. It's going to get very, very close, but it will never cross over. Now, later on, you may get to functions that may cross over immediately, but we'll get closer on. In fact, there are some rare sandwich functions that will actually cross over back and forth to infinity. So for this family of functions, they will actually stay on one side. You can almost think of it as an airplane. Let's see if I can draw a quick airplane here. And that airplane is coming straight down, and he says, "Whoa, I better pull up." And tries to pull up, and hopefully he never actually touches the ground, but gets very, very close, which is a fantastic explanation, but gives you a general idea. Now, if you look through, look at the x values, left to right. If I keep going to the left, towards the negatives, I can go to negative infinity, no problem. So the domain is going to include all values to negative infinity. If I keep going to the right, I will increase and keep going, keep going, keep going. I will go to infinity as well, going to the positive version here. So left and right, it's going to include all values. So the domain, as far as the x values go, the domain is all real numbers. Because on the x-axis, if you were to sort of squeeze this onto the x, you see there's going to be some value on the x-axis all the way across. So the domain is all real numbers. Now if you try to sort of squeeze this onto the y-axis, you notice we're going to have a value to squeeze onto the y-axis, trying to get it onto the y-axis, up to 0. But here, there's nothing to squeeze onto the y-axis. So the range, that is, all the values of y that are appropriate in this function, is going to be all real numbers that that are greater than 0. And it's important that it's not greater than or equal to 0. You can never actually get to 0. Very, very close. Can never actually get there for this family of functions. Okay, let's try another one here. Again, we're going to start with the same set and really the same start to our x values, our table. All right, so y equals 2, and then to some power plus 1. Okay, so to the negative second power. Well, to the negative second power, that is going to be, I'm going to put that over 1. Chuck Norris boots him down. We have 1 over 2 squared plus 1. That's 1/4 plus 1, or 1 and 1/4. Okay, let's plug in another one. We have negative 1. So 2 to the negative first power. That's going to boot him down. Y equals 1 over 2 to the first plus 1. That's 1/2 plus 1, or 1 and 1/2. Let's try to the 0 power. 2 to the 0 power, unless there's an opposite of. Now, if it's in parentheses, it would still be positive 1, but if it's not in parentheses, that'd be negative 1. 2 to the 0 power right now, that is positive 1 divided by 1 is 1. So y equals 1 plus 1 will be 2. Let's try positive first power. 2 to the first is 2. 2 plus 1 is 3. 2 squared is 4, plus 1 is 5. And that should be enough for us to get the basic picture of this graph. Negative 2, 1 and 1/4. Negative 2, 1 and 1/4. Negative 1, 1 and 1/2. 0, 2, 1, 3, 2, 5, and so on. And if you really think about this, we have 0, 2, negative 1, 1 and 1/2, negative 2, 1 and 1/4. Next, you would have negative 3, 1 and 1/8, 1 and 1/16. And so it's going to be very, very close. You can see this asymptote coming, which is going to be this line y equals 1. So y equals 1 is your asymptote. You have a horizontal, that is to the left and the right, asymptote. So you have an asymptote of y equals 1. And let's see if we can graph this. The reason I put the asymptote first is because it gives me sort of a guide. If I cross over this asymptote, that means that I have not graphed it correctly. Very, very close there, best I can. All right, and so there we have it. Now let's look at the domain and the range. The domain, let's see what we can squish onto the x-axis. So I can assign, you can see there's a value for x here, for x here. I can squish all of these. Even though it goes off the graph, I'm still going to be able to put values assigned to this x-axis. So all of those I can sort of squish onto the x-axis. So there's going to be no limits to what I can use that can assign to the x-axis. It's going to go on, and there's going to be all real numbers involved. The range, if I look at the range, I can assign a value here, I can sort of squish on. I can assign values here, but I'm never going to be able to assign a value quite to positive 1. It's going to be greater than 1. So have all real numbers greater than 1. Because I cannot squish any of these points onto the y-axis any further than 1, definitely not past 1. All right, let's try another one. Again, -2, -1, 0, 1, 2. You can pick different values, but these are probably going to give you a pretty clear picture without going into too much detail. Let's go ahead and plug in y equals 2 to the some power minus 1. 2 to the negative second, that's going to be over 1. It's going to be 1 over 2 squared. Minus 1, that's 1/4. Minus 1. You can think of 1 as 4/4. So it'd be y equals 1 minus 4 would be -3/4. So -3/4. All right, and -1 to the negative first power, that's going to be 1/2, or 1 over 2 to the first power, minus 1. You can think of 1 as 2/2. 1 minus 2, -1. So that'd be -1/2. Okay, plug in 0. 2 to the 0 power, there's no negative here that we have to worry about. 2 to the 0 power is going to be 1. 1 minus 1 is 0. All right, 2 to the first power is going to be 2. So 2 minus 1 is 1. 2 to the second power. 2 to the second power is 4. Minus 1 is 3. And so we have a basic shape of this function here. -2, -3/4. So if you were to split it into 4 parts, you'd go 3 parts of the way down. Not quite -1. probably be a little bit further down. -1, -1/2. Let me move that down just a little bit. Uh, 0, 0, 1, 1, 2, 3, and you can see where it's starting to go exponentially higher. Now, this would be -3/4, then -7/8, then -15/16. Very, very, very close. So you can see this asymptote starting to develop here at -1, y equals -1. Go ahead and sketch your horizontal asymptote. Right there at y equals -1. Okay, so let's talk about, well, actually first let's sketch our the domain. I can, if you will, just sort of squish values down onto the x-axis to infinity, either way. I'm always going to be able to find some value. Oops, excuse me. I did to the asymptote, not to the x-axis. So I'm going to be able to assign values here, be able to sort of draw it down to the x-axis for to positive infinity and negative infinity. So the domain is going to be all real numbers. The range I'll be able to assign values or sort of squish it onto the y-axis only to a certain point. You see, once we get to y equals -1, then there's definitely a limitation here. So the range is going to be all real numbers that are greater than -1. Okay. Now, if you look at the big picture, you notice this is the sort of parent function. And when you add 1 at the end, the asymptote has moved up 1, and so has the range been affected, greater than 1. So everything's been shifted up 1. When you subtract 1 in this location, not in the exponent, but just regular subtraction, then you notice the asymptote has been shifted down. Everything has been shifted down 1 unit. So let's investigate what's going to happen when we have the opposite of 2 to the x. Okay, so y equals the opposite of 2 to the some power. And just deal with the basic function here. Go ahead and predict. What do you think is going to happen to this thing? Okay, let's see if that turns out to be the case. Let's plug in our -2. This is going to be y equals. Now, we're going to sort of think of this as -1 times 2 to the -2nd. So it's going to be 1 over 2 to the 2nd. So this is y equals -1/4. Let's plug in -1 and see what happens. This is really sort of -1 times 1/2. It's going to be -1/2. Plug in 0. Now, this is interesting. This is the opposite of, there's a difference between opposite of 2 all in parentheses to the 0 power and the opposite of 2 to the 0 power. The difference is this. In this scenario, they're describing as many negative 2's, plural, on the top as on the bottom, and that's going to be a positive 1. Whereas in this scenario, they're saying the opposite of as many 2's on the top as there are on the bottom. And so in this case, we're going to have a negative 1. So be very careful with the distinction here. If there's parentheses, then it's going to be a positive 1. If there's not, then it'll be a negative 1. Okay, so the opposite of 2 to the 0, that's going to be the opposite of 1. So negative 1. Very tricky right there. Okay, the opposite of 2 to the first. Well, that's just negative 2. The opposite of 2 squared. It's going to be y equals negative 4. And let's see what happens here. Negative 2, negative 1/4, negative 1, negative 1/2, 0, negative 1, 1, negative 2, 2, negative 4, and so on. Alright, and we're going to go ahead and sketch the best we can. It's hard to do. You can see this horizontal asymptote developing. That is at y equals 0. So the same horizontal asymptote let's look at the domain and the range. The domain, I can sort of assign values onto the x-axis all the way through. Even though this keeps going off, you can definitely tell that there's going to be something for that x-axis. So this is going to be all real numbers. Whereas the range, I can only assign so much. I can go onto the y-axis all through here, all through here. But as soon as I get to y equals 0, there's just not a value there. So that is as far as it goes. All real numbers less than 0. So let's see if your prediction was correct. The prediction was that it would just simply, instead of going up, it would go down. And that is correct. You take the parent function and you simply make it go down on the bottom side, if you will, of the horizontal asymptote instead of going up. All right, and x, y, negative 2, negative 1, 0, 1, and 2. Let's plug in. All right, again, be careful. This is negative 1 over 2 squared plus 1. That is negative 1, that's a 4, so negative 1/4 plus 1. You could think of that as negative 1/4 plus 4/4, which is going to be positive 3/4. Okay, negative 1. Negative 2 to the negative first power, that's y equals negative 1/2 plus 1. Negative 1/2 plus 1, you can think of that as negative 1/2 plus 2/2, which is positive 1/2. Okay, and this is negative 2 to the 0, or the opposite of 2 to the 0. 2 to the 0 is 1. This is just the opposite of. There's not parentheses here. That would have made a huge difference. So y equals negative 1 plus 1, which is 0. Let's plug in 1. So negative 2 to the first, that is negative 2, plus 1 is negative 1. So the opposite of 2 squared plus 1, that's negative 4 plus 1, which is negative 3. And now we can graph this. Negative 2, 3/4, negative 1, 1/2, 0, 0, 1, negative 1, 2, negative 3, and it gives us enough of a shape that we can go ahead and sketch it. Be careful that this never goes completely vertical. It gets near vertical, well on down the line, but never quite absolutely vertical. That would affect the domain very substantially. All right, and our horizontal asymptote here at y equals positive 1. So the domain, again, you're going to be able to put this on, assign values throughout on the x-axis. So as far as the x values go, all real numbers. As far as the range goes, it's going to be all real numbers less than 1 here. Here's the positive 1. Just below that, I can assign values there to the y-axis. It's going to be all real numbers less than 1. And again, you look at the parent function, the negative in front seems to have flipped it upside down, and then plus 1, you take the flipped version and move the asymptote and the entire graph up 1. So you can see this is starting to become very predictable. In fact, we would predict this one, because the negative is going to make it sort of upside down, going down, and we're going to move it down 1. So asymptote here at negative 1, and moving down is our prediction. Let's see if that's true. Let's start off with negative 2 to the negative second, the opposite of 2 to the negative second power minus 1. This is really the opposite of 1 over 2 squared minus 1. Y equals the opposite of 1/4 minus 1. And so really this is negative 1 and 1/4. All right, negative 2 to the negative first. That's the opposite of the opposite of 1 over 2 to the first minus 1, or just y equals negative 1 and 1/2. Okay, to the 0 power. The opposite of 2 to the 0. Well, 2 to the 0 is 1. The opposite of 1 is negative 1. If I had parentheses here, that would change that, but we don't have parentheses there. Negative 1 minus 1 is negative 2. Negative 2 to the first power, that's just negative 2. Minus 1 is negative 3. And negative 2 squared, or the opposite of 2 squared, minus 1, that's negative 4 minus 1 is negative 5. Let's see if we can sketch our graph. -2, -1 and 1/4, -1, -1 and 1/2, 0, -2, 1, -3, 2, -5, and this gives us enough of a picture that we can go ahead and graph. And you can see the horizontal asymptote emerging there at y equals -1, which is exactly where we thought it would be. Now I know it looks like this is on that asymptote, and that was unintentional. It never actually goes to -1. It's very close, but never actually approaches. Alright, so, or excuse me, it does approach. It just never actually quite gets there. The domain is going to be, again, as far as the x values go, I can assign an x value for each one of those places on the x-axis. So the domain is all real numbers. Whereas the range is going to be all real numbers less than this asymptote, which is -1. So all real numbers less than -1. Okay, now let's talk about what happens when we have a little different number there for the parent. That is, instead of y equals 2 to the x, what happens when we have y equals 3 to the x? And again, I'll speed this up just a little bit. I know the video is starting to get a little long. Okay, so we're going to plug in these values. It's going to be y equals 3 to the -2nd. That's y equals 1/9. To the -1st is going to be 1/3. The 0 power will be 1. The first power will be 3. Second power will be 9. So -2, 1/9. -1, 1/3. 0, 1, 1, 3, 2, and so you can see what it's doing is it's making the graph much, much steeper more quickly. Okay, and the same horizontal asymptote at y equals 0. Okay, so my domain is going to be all real numbers. My range is going to be all real numbers greater than 0 here. Now, as you could sort of predict here, what's going to happen is we're going to take these same values and just add 1 to all of them. It's going to take that asymptote and move it up 1. And so again, this is just going up extremely quickly. The larger this base becomes, if this were, say, y equals 10 to the x plus 1, of course, that'd be very, very quick growth. Actually, need to correct myself there. On to the right, numbers greater, values greater than 0 on the x-axis of the domain, it will be very, very quick growth. values less than 0, it will be very, very quick decay here. All right, and so the asymptote here is going to be at y equals 1. The domain will still be all real numbers. The range will be all real numbers, let's see, greater than 1. And here, again, we're just going to subtract these values. Subtract 1 from all of these values. Same exact idea. And try to sketch this the best we can. Very weak graph here, but you get the idea. Again, the horizontal asymptote at y equals -1. And our domain and range. Domain is going to be, again, all real numbers. The range is going to be all real numbers greater than -1. We're going to take these same values and go in the opposite direction. Take the opposite of them. Again, plugging in here. Sketch that graph. Okay, the asymptote here, you can see it's approaching 0 on the x-axis. So that is a horizontal asymptote. Although we'll get to other families who have different asymptotes. Y equals 0. The domain is going to be all real numbers. The range will be all real numbers less than 0. Alright, so we're going to take these values and add 1 to them. And again, we have the horizontal asymptote of positive one, and one last for the graphing. You can see a little corner there on my graph. I really shouldn't have a corner. It should be a smooth curve. And so there we have our asymptote at y equals -1. And our domain is going to be, again, all real numbers. And the range is going to be all real numbers less than -1. Now let's look at what actually happened here. How does C affect the graph? Well, what C is going to do, the number C is actually going to affect how quickly the graph grows and decays. You can think of it how quickly it snaps to the graph. So here, with the base of 3, goes up very quickly, snaps down very quickly. Whereas with the 2, it's a little more gentle of a rise. If you had, say, a 10 or even a 20, it would stay very, very low and then snap very quickly up. When graphing the exponential function, how does b affect the graph? Well, what b is going to do, b affects the horizontal asymptote. You could also say it moves the graph up and down. How does A affect the graph? Well, if A is positive, then the graph will open up. If it's negative, the graph will open down. So effectively, it's going to invert the graph up or down. Were there any patterns associated with the range? Well, basically, the range is linked to the b in y equals a times c to the x plus b. If the graph opens up, then the range is all real numbers greater than b. If the graph opens down, then the range is all real numbers less than b. And that will do it for Crazy Math Productions today. Thank you so much for watching.